An astrophysicist from Yale, known for deep theoretical work, believes we need bold thinking to understand a strange discovery. Something unexpected has appeared at the edge of the known universe, so unusual that even Nobel Prize-winning scientists are talking about it. The James Webb Space Telescope, JWST, the most powerful space telescope we have, has found more than just a beautiful image. It uncovered something that doesn't belong. This mystery might change how we think the universe began. Could it be a missing piece in the universe's story? Or does it show we've misunderstood the cosmos? As we look deeper into space, we also look further back in time. What JWST has seen might not match the past we believed in. JWST is the most advanced space telescope ever created, designed to explore the earliest moments after the Big Bang. Unlike the Hubble telescope, which mainly sees visible and ultraviolet light, JWST is made to detect infrared light. This is important because as the universe expands, light from very old galaxies stretches and turns redder, a process called redshift. Infrared light helps JWST see further back in time, to when the first stars and galaxies were just forming. It can observe objects from just a few 100 million years after the Big Bang, a time called the cosmic dawn. JWST has a large 6.5-meter mirror and is placed far from Earth to avoid heat and light interference. It uses a special sunshield to stay extremely cold, which is needed to detect faint infrared signals from distant galaxies. One of its first big successes was the Deep Field image, which showed thousands of galaxies in an area once thought empty. Many of these galaxies seem too old and fully formed for the early universe, surprising scientists. With instruments like NIRCam, NIRSpec, and MIRI, JWST not only takes pictures but also studies light from galaxies. This tells scientists about their chemical makeup, how fast stars form, and how the galaxies move. A galaxy named JADES GS-Z13-0, believed to have existed only 320 million years after the Big Bang, has caused real confusion. How could such large, bright galaxies form so quickly in a young universe? These discoveries are making scientists rethink what they thought they knew about how the universe developed. JWST has found galaxies that seem to have used almost all their gas to make stars, something once thought impossible. Normally, star formation is controlled by things like supernova explosions. But these galaxies don't seem to follow those rules. If the findings are proven true, it might completely change the standard model of how the universe works. In less than a year of operation, JWST has not only expanded how far we can see, but also changed what we believe about how everything began. Looking far into space is like looking back in time. Light travels at a set speed, so when we see light from very far away, we are seeing how things looked billions of years ago. JWST lets us view galaxies as they were just a few 100 million years after the Big Bang. The more distant the object, the older the light we see. That's how astronomers build a timeline of the universe's history. For example, when we look at a galaxy 10 billion light-years away, we're seeing it as it looked 10 billion years ago, long before Earth existed. Because the universe is expanding, the light from distant galaxies gets stretched and turns red. JWST is specially made to detect this stretched infrared light, which older telescopes like Hubble couldn't see. Instruments like NIRCam and MIRI help scientists study these ancient galaxies and understand how stars and galaxies formed in great detail. JWST doesn't just take pictures, it helps us understand how the universe changed over billions of years. One of the most amazing things JWST has found is galaxies that seem much older and bigger than they should be for their age. Some, like JADES GS-Z13-0, appear to have existed only 320 million years after the Big Bang. But they already look bright, full of stars, and well-formed. According to current theories, galaxies should take hundreds of millions of years to form. Gas needs to cool and collapse, and star formation is usually slowed down by energy from exploding stars. But the galaxies JWST sees seem to have formed stars very quickly, using up almost all their gas in a short time. This goes against what we believed about galaxy growth. Scientists are now looking for answers. Maybe the early universe had gas that was cooler and denser, allowing it to collapse into stars more quickly. Or perhaps these objects aren't galaxies at all, but instead are supermassive black holes, called quasars, shining brightly and tricking us into thinking they're full of stars. JWST's tools can analyze the light from these objects and help us tell the difference. If JWST confirms that these galaxies really are as mature as they seem and existed that early, it could change how we think about galaxy and star formation and even the age of the universe. Some scientists have even suggested that the universe might be older than we thought, or that new, unknown forces helped galaxies form faster. Either way, these galaxies are forcing us to rethink our ideas about the early universe. The standard Big Bang model says the universe began 13.8 billion years ago. At first it was hot and dense, then it cooled and formed neutral atoms, and only much later did stars and galaxies start to appear. According to this model, big and fully formed galaxies shouldn't show up until at least 500 million years after the Big Bang. But JWST has found galaxies that are massive and well-formed just 300 to 400 million years after the beginning of the universe, challenging that timeline. These galaxies don't match what current theories predict. They are brighter, heavier, and more structured than expected. Some of them seem to have already used most of their gas to make stars. This suggests that star formation in the early universe may have happened much faster than we believed. That makes scientists question whether our timeline of the universe is correct. Some researchers now wonder if the universe is actually older than 13.8 billion years. Others think that galaxy formation in the early universe was just faster because of different conditions, like colder or denser gas, or that there are unknown physical processes at play. There's also a chance that we're misreading the data. Some of these galaxies might be black holes or something else entirely. Even though JWST's observations support the idea of early galaxy formation, scientists are still cautious. They are double-checking redshift measurements and considering other explanations like gravitational lensing or observational mistakes. But if JWST keeps finding more mature galaxies from the very early universe, we may need to accept that the universe is either older or evolved differently than we thought. At the very least, this shows that the early universe was much more active and complicated than we had imagined. Star formation in the early universe was always thought to be a slow and controlled process. Only a small part of the available gas was believed to turn into stars at a time. Energy from exploding stars and other events would stop too many stars from forming at once. But now JWST is showing us something different. Some early galaxies seem to have turned nearly all their gas into stars very quickly. This kind of rapid star formation is not supposed to happen according to our models. These galaxies are big, bright, and full of stars, even though they formed just a few 100 million years after the Big Bang. If these galaxies are real and not errors in observation, then our ideas about galaxy formation need to be changed. One possible reason is that gas in the early universe was cooler and denser, which made it easier for gravity to pull it together and create stars. Another theory is that maybe these galaxies formed in an unusual way that we don't yet understand. Scientists are now working hard to find out what these galaxies really are and how they formed so fast. These findings from JWST are giving us a brand new view of how the first galaxies and stars came to be. Dark matter and dark energy play important roles in explaining how the universe works, but no one has directly observed them yet. Scientists only know they exist because of the way they affect gravity and how the universe is expanding. But recent discoveries made by the James Webb Space Telescope are making scientists question whether our current understanding of these mysterious substances is actually correct. The telescope has found galaxies that are surprisingly large and fully formed, even though they appeared just a few 100 million years after the Big Bang. According to current theories, there hasn't been enough time for such big galaxies to form. This challenges the idea that the universe developed slowly with the help of dark matter. Because of this, some scientists are now wondering if dark matter acted differently in the early universe than it does today. There are suggestions that other kinds of dark matter might exist, types that gather together more quickly or behave in unexpected ways. Instead of the commonly accepted cold dark matter, scientists are looking at the possibilities of warm dark matter or self-interacting dark matter. These forms might better explain the fast formation of early galaxies. Other scientists are focusing on dark energy, asking if it could have behaved differently in the past than it does now. If dark energy changed over time, it might have allowed galaxies to form faster, which could explain the surprising observations without having to abandon the standard model entirely. Some even believe we need to go further and rethink the basic laws of gravity. These alternative theories try to explain the effects we usually link to dark matter and dark energy by changing how gravity works. However, these ideas often don't match all the observations we've made. Still, the new data from JWST is making scientists consider these possibilities again. The fact that such early, massive galaxies exist shows that we might still be missing important information about how the universe works. Even though the current model, known as lambda CDM, still explains many things, like the patterns in the cosmic microwave background and how galaxies are arranged, it may not tell the whole story. The discoveries made by JWST are forcing scientists to take a closer look at long-standing ideas. This might lead to the discovery of new particles, a change in how we understand the laws of physics, or a better explanation of how dark matter and dark energy change over time. The cosmic microwave background, or CMB, is the oldest light in the universe. It comes from about 380,000 years after the Big Bang, when the universe cooled down enough for electrons and protons to combine into atoms. This allowed light to travel freely for the first time. That ancient light, stretched by billions of years of expansion, is now seen as microwave radiation. Satellites like WMAP and Planck have mapped tiny temperature differences in the CMB. These small changes in temperature show the early differences in density that led to the formation of galaxies and large structures. The CMB has helped shape our understanding of the universe by giving us precise measurements of how much matter and energy it contains, how fast it was expanding early on, and more. It also supports the theory of inflation, which says the universe expanded extremely fast in its first moment. This helps explain why the CMB looks almost the same in every direction. Even though the CMB fits our current models well, it also has some strange features, like a cold spot, that could be signs of physics we don't yet understand. Some scientists even think these could be clues to a multiverse, where our universe may have bumped into others in the past. JWST doesn't study the CMB directly, but it does something just as important. It looks at galaxies that formed a few 100 million years after the Big Bang. This helps scientists compare what they see with what the CMB tells us should have happened. If the galaxies found by JWST are much bigger or more developed than expected, it might mean that our ideas about the universe's development need to be updated. So, if JWST keeps finding early galaxies that don't match the predictions based on the CMB, it could point to missing pieces in our knowledge of the early universe. These gaps might involve how dark matter behaves, how inflation worked, or even what the starting conditions of the universe were like. By linking the earliest light from the CMB with the first galaxies JWST sees, scientists are creating a more complete and possibly more complex picture of how everything began. As more strange and unexpected discoveries come in, scientists are starting to ask if we need a completely new theory of the universe. The standard model of cosmology, called lambda CDM, includes the Big Bang, inflation, cold dark matter, and dark energy. It has been the main theory for many years. But now, with JWST finding well-developed galaxies only 300 to 400 million years after the Big Bang, people are beginning to question whether this model can fully explain everything. These galaxies seem too evolved for their age. That could mean our understanding of how stars and galaxies form needs to change. Researchers are checking to make sure there weren't mistakes in how the galaxies' distances or masses were measured, but if the findings are accurate, then it means galaxies formed earlier or faster than we thought possible. This has led scientists to come up with new models of the universe. Some ideas suggest that structure formation began sooner or happened more efficiently. Others suggest new kinds of physics that aren't part of the current model. Some of the more unusual theories include ideas from quantum gravity, universes that expand and collapse over and over, or a changing speed of light. A few scientists even propose that the universe didn't start with a single Big Bang, but came from a previous state or another cycle of existence. Well-known physicists like David Gross and Adam Rees have said that times like this, when current theories run into problems, are often when the biggest breakthroughs happen. These moments can bring together old and new ideas, especially when trying to connect the tiny world of quantum mechanics with the huge scale of the universe. So far, none of the new models have fully replaced the standard one. But the unusual observations from JWST, as well as other puzzles like the Hubble tension, show that cosmology is going through a major turning point. Future missions like the European Space Agency's Euclid and NASA's Nancy Grace Roman Space Telescope will gather more data to help confirm or challenge current theories. Either way, it seems we're entering a new era in our understanding of the universe, one that might completely change how we think about space, time, and where everything came from. Other ideas, like modified Newtonian dynamics, MOND, and emergent gravity, are also being looked at again. These theories try to explain the universe without using dark matter or dark energy. For a long time, they were seen as alternative or less accepted theories, but the new findings from JWST are giving them a fresh chance. As Dr. Priyangvada Natarajan said, we may be seeing the breakdown of our current ideas about how the universe's structure formed. We may even need to rethink the fundamental forces we've always believed in. At the same time, philosophers and historians of science are comparing this moment to past scientific revolutions, like when we moved from Newton's physics to Einstein's relativity. They remind us that science doesn't just grow by finding answers, it also grows by asking better questions and rethinking the foundations we usually take for granted. Thanks for watching. If you found this as fascinating as we did, don't forget to like the video, subscribe for more mind-blowing space discoveries, and drop a comment below. We'd love to hear your thoughts. Ready to go deeper? Click the next video on your screen and continue the journey into the unknown. See you there.